Hello, I'm Devesh Labana and I will be presenting this spotlight video for our project, that is sentiment analysis project. So this is the list of our team members: Parth Kidia, Devesh Labana, Vishwaditya Ritnu, Shlok Agarwal, Devji Kumar and Nitish Gupta. So first, talking about the introduction. So what is sentiment analysis? It's a natural language processing task that detects sentiment or emotion in text. So the sentiment is usually classified as positive, negative or neutral. Its real-world applications include product reviews, social media monitoring. It will that is based on public opinion, customer support, that is filtering urgent or negative complaints, and politics, which is very common for analyzing the tweets during elections. And now our problem statement and objective. So what was our problem? It was people express their opinion about product, service, politics, etc. online through text, and manually analyzing each response is time consuming and impractical, especially with the vast amount of content being generated every day. So based on that, our objective was to classify a given text input into one of the three possible sentiment, that is positive, negative or neutral. And so this would help businesses and organizations automatically understand customer feedback and improve decision making processes. So talking about the dataset overview, so our source was Kaggle, and we took the Sentiment 140 dataset, a publicly available dataset with labeled sentiment data. And the key details included: the main features were text, that is the tweet or the text content, and the sentiment, that was the label for sentiment. Either the text was positive, negative, or neutral. So this was the main column. These were the main features of the dataset, and it contained around 16,000 labeled examples, balanced across positive, negative, and neutral sentiments. Now, talking about the modeling approach, first we talking about pre-processing. First step was text normalization. It included converting text to lowercase to ensure uniformity and removing punctuation as special characters and stop words. Then vectorization, we used TF-IDF to convert text data into numerical form. This helps in capturing important words in the text while ignoring the less useful ones. Then we use seven different models in our project: logistic regression, linear regression, naive Bayes, XGBoost, support vector machines, random forest, and k nearest neighbors. And the tools that we used were Python, scikit-learn, NLTK, XGBoost, and Flask. And when we talk about the accuracy comparison, the logistic regression 83%, linear regression 19, naive Bayes 78, XGBoost 80, SVM 84, random 80, KNN 69 respective, and these are approximate figures, and the real figures are listed here. And talking about insight, the best performers were SVM and logistic regression. They performed their best with accuracy above 83%. And the worst performer, it included linear regression. Being a regression model, it did not perform well for classification tasks. Since our project was to classify the sentiment of the text into positive, negative, or neutral. The XGBoost and naive Bayes model were also competitive, performing slightly below SVM and logistic regression. The challenges we faced were, first, it was Kaggle API token. The setting up the Kaggle API token for accessing dataset in Google Colab was tricky and needed careful handling. Model management, handling and storing multiple models required good version control and organization. Third, integrating multiple models into Flask. Ensuring smooth integration of different trained models into the web app was more complex than expected. Our main learnings were: we gained hands-on experience with NLP and ML. We learned how to deploy machine learning models in web application using Flask. The project provided valuable insights into handling challenges related to data pre-processing, model training, and deployment. The conclusions were: we successfully built a sentiment classification system that can automatically classify text into positive, negative, and neutral sentiment. We compared and deployed the best performing models in a live web app. And the future scope includes multilingual support, deep learning models, and larger datasets. Thank you.